vehicle has to go a little bit faster, but it's still small by comparison with what's needed for the Volt, for example. The Volt has a 16 kilowatt hour battery. This battery is about 5 times smaller. This slide basically shows that it's a two-layer chassis. In a Segway, you accelerate by leaning forward and you brake by leaning back. That's how you shift the center of gravity when you operate a Segway or a balancing machine. Well, when you're sitting down in this vehicle, it's not very easy to keep on moving your back and forth. So we decided instead we're going to have a slide mechanism instead. So the top layer of this chassis actually slides with the coach. So the battery pack and the coach slide together. So when you want to drive the vehicle and you command torque, the coach with the batteries moves forward and then the wheels are momentarily left behind, and to prevent the vehicle from falling over, the wheels move forward to catch up. A little bit like walking. That's how we balance. So it'll be something that you notice when the vehicle moves off, when it accelerates. You'll see that the coach moves first and the wheels catch up with it. And the opposite happens when you brake. The second piece of the puzzle is the connectivity, because no matter how clean and efficient you make the vehicle, if it's not connected with other vehicles, can't communicate and coordinate its actions with other vehicles, it's not going to address the congestion. It's not going to be able to find parking any more easily than today's cars. So the networking and connectivity is very important. At GM, we've been developing autonomous vehicles for several years, and we've been looking at two different approaches which complement each other in the NV. The first approach was demonstrated in the Urban Challenge 3 or 4 years ago, where we worked with Carnegie Mellon, and it's basically a sensor-based approach. Putting a lot of sensors around the car so the vehicle could drive autonomously with nobody in it is one approach. We've also been demonstrating at GM what we call vehicle-to-vehicle communications, where the vehicles communicate with each other.